on the current, on the today's presentation. Okay, you're going to look at the components. Okay, we are going to look at components, and this presentation today is specifically for loss adjusters, insurers, and failure investigators. Sometimes you go in, you look at some sort of failure, and the failure could have been coming from certain main components of this boiler. But since you do not have insights of these components, people tend to overlook those. And there's always a debate between wear and tear, uh, maintenance, poor maintenance, negligence. Then comes in the perfect word finally, not sudden and unforeseen or foreseen. So if you do not do a proper maintenance on a certain equipment, the boiler or any machinery would start prompting deviation in its parameters or in its item which is supposed to be produced by this machine. So by that, you can consider it foreseen already. Sudden and unforeseen is something which happens abruptly. So in today's um, slides, the webinar today, what I would like to give you all is basic insights which you can relate to every time you look at failures in boilers. Mostly it will revolve around these. Sometimes, not rare cases, sometimes it could go into some other areas of this boiler as well. Sometimes it could be electrical, software, operator error, and all that. But what we are trying to concentrate on is we are trying to rule out certain areas by whatever I'm going to explain today. So when you look at certain type of failures, you can straight away try to relate these into that particular component of this machine, and you can rule out if they are not, feasible for your failure investigation or not relevant. I would say that's the right word. Okay, shall we go? Okay, 2 more minutes. As per my team, we've got to wait another 2 more minutes before we can proceed. Anything interesting, guys? How is COVID handling you? Or how are you handling COVID? So, how is work from home? Most of you all, sir, no sound? Oh, everyone is like that. So, I think COVID is handling them well. Or just recovered. Oh, wow. Farhan, you just recovered? You were affected by COVID? My God, how are you feeling now? Are you okay? So Navendran, thank you all. Good to hear you're doing okay. Screen loading error. I believe all of you all are working from home. Fortunately, I'm fine right now. yeah, I'm glad that you're fine, Farhan, and you're able to attend the webinar today. Wilco surviving. Is this the Wilco I know? Yeah, I think so. I'm glad that all of you all are well, and I believe all of you all are following the current SOP standards, keeping your distance, working from home. I used to wear masks since I'm doing webinar, and I need you all to see my face. So I took off the mask. I'm still maintaining that 1 meter, 2 meters distance. My team is sitting nearly 2 meters away. Okay. Not my team, is actually just one person. Roshif is the one handling the whole background. You can see him replying there. Okay, guys, I've been given the cue to start. Okay, so today we are going to look at introduction to boilers. As I stated previously, the topic today is specifically tailored for loss adjusters, failure investigators, and also insurers who are looking into machinery failure cases. Obviously, anyone can join to have a better knowledge on boilers. So I'm going to look and show those items which will be related to the boilers today. So let's go on about, and what you're going to learn today is parts and functionality of boiler. When I say parts, don't hold me up there. Not all the parts. If I'm going to cover all the parts for you, it will not be the introduction to boiler. It will be a detailed course on boiler. We're going to look at the usual parts which you are going to relate to when you face a failure. Okay. So next one, possible causes of failure and how you can determine this failure, what you can do, what you can check. Okay. And then risk assessment. How are you going to mitigate the risk and assess the risk before it's going to happen? I think this is more of the operator or the insured side, but it's good for us to know as well, right? Okay, so this is how we are going to go. Under the boiler, there are two major sections which is going to decide the boiler's operating condition: combustion control and heat transfer. As you know, the boiler itself is going to transmit heat to water and produce steam. Then, to ensure the smooth operation of this boiler, there's something called boiler mountings. If you look into books on boiler, if you look into blogs on boiler, you might find a longer list, a bigger list, something called, as boiler mountings and accessories. Okay, but the most important seven major mountings are this. This is the one ensures a boiler safe and smooth operation. So let us start with the operations related items first, and then we'll go into the mountings which ensures the safety and smooth operations as well. Okay, so introducing boiler, I believe all of you all know it is a pressure vessel which produces steam. Okay, steam which is being produced by this boiler is used to do work. What kind of work? It could be mechanical work, it could be thermal. If it is used as a heater, boilers produce steam is going to be sent into a heat exchanger, plate type heat exchanger, a heating coil inside the oil tank. So the work done there is thermal. And then you go into mechanical work. The steam, the pressure produced by the steam, the high pressure steam goes into a turbine and turns the turbine, which in turn turns the alternator. So you have a mechanical work there. So these are two examples. So this method of utilizing steam can be varied depending on how the person is going to design his plant or work he wants to do. Okay, so for this boiler to function as it is and do what it is required to do, some parts come in together. See, boiler, when you say it is a vast subject, you will have multiple types of boiler. You have smoke tube boiler, water tube boiler, horizontal fired boiler, vertical fired boiler, gas fired boiler, coal fired boiler. I can keep going, but generally, when you look at a boiler, these parts will be there. This seven mountings and this combustion and heat transfer is going to be there always. So you will never run out of these items in any other boilers you go. Let's say you're going to go and tackle a failure investigation and you're going to ask a guy, show me where is your steam stop valve. Or if the guy comes and tells you that, this is a different type of boiler, I don't have a steam stop valve, you tell him that, no, this is a general thing which all boilers should have, you should show me. Probably he doesn't understand or he thinks you don't understand. That's it. Okay, let's go on about it. Okay, so boiler, this is a horizontal fired smoke tube boiler. Okay, you can see the GIF image processing itself. Okay, so you have your FD fan, you have your burner. I'm going to change into my pointer. Later we are going to see this in detail even better, okay, in a 2D diagram. I'm just going to show you that. Don't get confused. This is a combustion integrated system where you have the FD fan at the back, the forced draft fan, together with the burner, and the fire is there. You know the water is there. The smoke travels through, hits up the water. Then there you have steam. Steam is flowing out through here. This valve. This is the steam stop valve. You have a safety valve here, and you have a gauge glass to determine what is the level of water inside your boiler. Okay, I'm going to stop you. I'm going to stop in between to see any questions. Okay, if you have questions, you may ask your questions in the chat box. My team will prompt that to me accordingly. Some questions which are very very important, which I need to address immediately, I will go on addressing those questions in between the slides. But for those questions which can be answered in the slides at the final point of the slide, I will hold on to that. Okay. If you have, just shoot on and my team will prompt. Okay, so I'm going to go on with the next slide. This is a 3D image to give you a bigger picture, or to give you a better picture on what is a boiler and how does a boiler work. So we're going to go on major parts of the boiler as I explained in what you're going to learn today. We're going to look at two major segments. One is the boiler combustion control and heat transfer, and boiler mountings. So when I say boiler mounting, combustion control and heat transfer, we're going to look at the whole picture here, and I'm going to show you what is this combustion control and heat transfer which I'm talking about. As I showed you in the 3D GIF image previously, okay, this is an integrated burner system which has the FD fan and burner together. So this is the FD fan, forced draft fan. It sends in a draft of forced air inside the furnace to assist on fire propagation and combustion. And then you have the burner, which does the actual heat producing work. And from the burner, you have the heat transfer medium, the tubes. Okay, you either have the water outside or water inside these tubes, and according to the radiation intensity of this combustion, you are going. The boiler is going to absorb the heat and transfer the heat into the water. Okay, so let's look into details of all these components under combustion and heat transfer. Okay, first and foremost is the forced draft fan. Okay, as I stated before, supplies the combustion air required, plays a major role in flame propagation. What is a flame propagation? I will explain in detail as we go down the slides. Okay, what is a flame propagation? What is a flame propagation? How the flame should be propagated? Okay, but remember that forced draft fan plays the major role in flame propagation. It's a centrifugal type of fan. You might ask me, what is a centrifugal type of fan? This is kind of like, imagine this is like a pump. Okay, pumps will do two stuffs. Okay, one gives flow and velocity to a liquid, or it gives pressure. They can be interrelated, but you need to know what is required of this fan to do. The fan needs to produce more volume of air, not more pressure. Heavy pressure will put off the fire. You need the density, the volume, okay, the volume of air required in the combustion chamber for a proper combustion to be achieved. So this fan is a centrifugal type of fan. It's going to just throw in air inside the furnace for combustion to be achieved. Okay, exactly as I said, flow is required, and this fan flow can be regulated through vanes at the outlet of these fans. Okay, there are vanes, flat vanes, which is integrated together with the boiler control system, and depending on the steam demand, the load is increased. According to that, air is allowed into the furnace. Okay, I have a question there. Pressurized, fluidized bed combustion. The type of boiler, pressurized. Please give me an example of this type of boiler. Okay, I do not know how to pronounce the name there. NTT. I will come back answering this question at the final slide, okay? Because if I'm going to talk about this, it is going to disrupt our flow of what I'm trying to explain here. There is a different type of boiler, but you will still find all this which I'm going to talk about here in this boiler. So just wait on a while, okay? Okay, this is your forced draft fan. In any boiler, you see, you will see a forced draft fan. The names might be slightly different, but the position of this fan will be before the furnace. The work of this fan will be to propagate and supply air for the flame. Okay, so how does this forced draft fan, what does it do and how it can cause failure is, see, when you have a combustion, you need a certain percentage of air for to achieve a certain amount of fire intensity. And the more intense the fire is, the higher the steam production is going to be in the boiler. So when you have a forced draft fan which is failing to supply enough air or adequate air, you're going to have incomplete combustion. This incomplete combustion is going to produce a lot of unburned fuel inside your furnace. Okay, that's number one. Number two, incomplete combustion will also produce a lot of soot. You know, it's going to have this carbon dust there produced around. In the surface of all these furnace tubes and wall. So how do we get rid of this? Again, the same forced draft fan is also utilized to do. Okay, well, I'm just looking at these questions which are coming in one by one. Could you adjust the sound to reduce the echo? Okay, what is the issue? Spoiler failure. Okay, Arif Rahman, I think the question is slightly out of topic. So I believe that I'll try to answer it. If it is out of topic at the moment, you can still ask me these questions in the end of slide. I will get back to you on that. Okay, let us go on because it will disrupt the flow of the webinar today if I'm going to answer these questions. It is not totally out of topic. I understand that you're talking about boiler, but still we need to understand all this before we can achieve that. Okay, so now coming back into it. So you need to purge the boiler. There must be a pre-purge and post-purge to get rid of all this unburned soot, fuel, and all that. So if your forced draft fan is not working well, then you're going to accumulate that inside and you will not be able to get rid of it as well. So failure to perform all this is going to lead into a furnace explosion. So how does this furnace explosion occur? You accumulate unburned fuel time and over again. So you have your FD fan. Your FD fan is unable to provide you the air required for a certain load. But your system picks it up as you have achieved that air required because due to sensor failure or it's due to some sort of linkage error, could be. So as it goes on, you're going to accumulate unburned fuel inside your furnace, and one point when the fuel is enough and the heat is enough, it's going to go kaboom. So the most important thing when you tackle a failure investigation which involves a boiler explosion, okay, don't get confused. A tube explosion is different from a boiler explosion. Means that boiler furnace explosion. So when a furnace explodes, that means there is accumulated unburned fuel inside the furnace which has exploded. So now, so when you see this, you please go and have a look at your forced draft fan. As a failure investigator, what is the condition of forced draft fan? A furnace explosion can also be caused by other stuffs, but we're going to look at forced draft fan first. So as a failure investigator, when you come across a furnace explosion, have a look at your forced draft fan. What is the linkage condition? What is the impeller condition? How does the forced draft fan look from overall point of view? Is it in workable condition? Is there any vibration? Is there any holes in the duct? Okay, this kinds of stuff you need to look at. So how can an operator understand whether this forced draft fan is going to fail, or is there an issue with the air ratio? So what you need to look at is the color of the smoke emitted out of the chimney. Okay, so how is it going to determine that? Usually you should have something colorless or transparent. You will not be able to achieve something transparent, literally transparent, because uh, that is a sign of perfect combustion. Okay, but you will have a slight whitish smoke, something like what you see here. Anything thicker than this, anything thicker than this means the oxygen amount is too rich inside. But it could also mean another thing. If your tubes are leaking, and if your tubes are leaking, then you'll be able to see steam coming out. So you will not be able to differentiate between a white smoke and a steam at times. So in order to understand whether it is due to your FD fan or your tube, what you can do is pressurize your boiler to the maximum, shut the main steam valve, okay, and then observe your chimney. If the boiler pressure is at its maximum, any leakage in your tube is going to come out through those areas, and you'll be able to see some sort of steam even when the boiler is not running, if your tubes are leaking. So after doing this, if there is no thick white smoke coming out of your chimney, and then when you start your boiler, you have that means your oxygen amount is too rich. You might need to adjust your linkage, or you need to look at how your boiler control is communicating with your FD fan linkage. Okay, and then finally you have thick black smoke. That means the fuel is too rich than the air, and this will leave a lot of unburned fuel. This is the dangerous part, which can lead to explosions if not attended to, if not troubleshooted. If you keep on going with that, then you are going to reach a situation where you can have a furnace explosion. So that's for forced draft fan under combustion control. So now we're going to look at, we've seen the air required for combustion. Now we're going to look at the fuel and the chain reaction which is going to produce the fuel. Okay, for a boiler, you require flame. You require some sort of heat. So this heat is achieved by pilot burners, pulverizers, and as per our previous command, FBC. Someone was talking about FBC. Yeah, okay. Go down, go down. Is the FD fan boiler with diesel? Yes, Andreas Adianto, you have asked a relevant question on FD fan, so I'm going to answer it straight away without further delay. FD fan, forced draft fan. Without air, you will not be able to achieve combustion in boiler. So whatever kind of boiler you have, you will have a sort of forced draft fan. You need air. Okay, so they might name it as something else, a blower or whatsoever, but the function will be the same. Okay, excuse me. So coming into flame now. Okay, flame can be established by burners, pilot burners, pulverizers, and pressurized fluidized bed combustion. You have given that example. Okay, for to answer Antich, you have already given the example for that particular boiler. Okay, that is fluidized bed combustion. So what happens is you literally liquidize the solid fuel, okay, at a certain temperature. You don't burn it, you put it in a chamber, and you are liquidizing this solid fuel, and this liquidized solid fuel is going to form a kind of bed in the furnace of this boiler, and your forced draft fan is going to blow from bottom to atomize this fluidized fuel, and it's going to burn. That's what is a fluidized bed. There is no particular example for this particular boiler, because there is an example. You can have water tube boiler, smoke tube boiler, and under this you have a combination boiler. Under combination boilers, then the rest follows. You can have a natural gas boiler, a coal-fired boiler, coal-fired pulverized boiler, a Stoker system boiler, or fluidized bed boiler. So it is a type of boiler by itself. Okay, now coming back to this, let us come back to our burners and pulverizers. I took that particular question out because we are going to talk about flame now. So that is one of those type of flames which can be achieved in a boiler. So they must be serviced at all times, periodically according to manufacturers' advice. So when you look at these burners, if the nozzles are choked, you need to clean them up. If the nozzles have gotten bigger due to the wear and tear, then you need to change them. So this will give you proper atomization and proper propagation of fire. So when we say propagation, what is a propagation? You are looking at on your right a GIF image of a pulverizer system. Okay, the coal is pulverized inside this pulverizer. The solid fuel is broken down into fine particles of dust, and you have gas burners at the sides of this boiler. So when the pulverizer pushes this flame, I mean the fine particles of dust straight up, and fire from the burners at the side due to their angle is going to form a cyclone inside the burner. Okay, it's going to form a cyclone. This cyclone is going to propagate the flame in such manner that they don't touch the tubes directly, but they're going to radiate the heat required for this flame, for this boiler to absorb the heat and produce steam. So this is called flame propagation. So if you don't have enough velocity or flow of air, you won't be able to achieve this propagation. At the same time, you will also not be able to achieve this propagation if your burners do not achieve proper atomization. Okay. So I've shown you one good type of fire propagation. Now I'm going to show you one bad type of fire propagation as well. So I've been explaining what it could do, how it's going to be, okay? And what we are trying to show you now is, let's say if the atomization is not proper, what is it going to do? Again, same thing like what we have stated in the FD fan section, you're going to have unburned fuel. See, for a fire triangle to, for a fire to occur, you need to complete the fire tetrahedron. Number one is the fuel. Number two is the ignition source. Number three is the air. Okay, and the the uninhibited chain reaction. So all four must be complete. So we have completed the air, and the heat required is produced by the pilot burners or sparks. Okay, you've got that, and you've got the fuel, and you've got the continuous supply of fuel which will establish the flame. Now, since we have covered the air, and if air is not enough, what it's going to do is not able to complete the combustion properly, so you're going to have with a lot of unburned fuel leftovers. Same thing is going to happen when you are at this stage as well. Okay, if your atomization is not proper, you are going to see a lot of unburned fuel, which can also cause explosion inside the furnace. For biomass boilers, you have gas burners at the side. You push in fresh biomass and they burn this biomass. And once the biomass has caught on fire, they will stop the gas burners. So in order to achieve this proper heat radiation, you must ensure your fire system or your flame producers or your heat producers, this system is working well. So I've given an example on your right again. You see, this flame which you are looking at inside the furnace is not a proper propagation. It is scattering everywhere. You will not be able to radiate the heat required to the areas where you want it to go if your flame is scattering everywhere. You need to propagate the flame in such a way, either in a cyclonic manner or it's going to be, a spear manner for it to radiate well. So we have seen the combustion control. Now let us look at the heat transfer component of the boiler. We all know the heat transfer component of the boiler is the tube. Most of the boilers use carbon steel. If you ask me, is there any other type of boiler tube? Yes, they are, but they are used in much more complex kind of reactors. Let's say like nuclear, they use different kind of tubes. So mostly, so how does this heat transfer has been achieved is that the combustion occurs. First, it radiates the heat onto the tube surface. Then once the tube absorbs the radiated heat, you have you have conduction. Okay, now the tubes heat is going to conduct towards the liquid which is inside the tube or outside the tube. So then finally the flue gases which are flowing is going to exchange heat through convection, and that's how you're going to transfer all the heat through the combustion to the water to produce steam. So this is one type of tube. It's a horizontal type. You have your shell from horizontally. You will have your burners on the other side, okay, which is going in as well. So in this tubes, how failure could occur is failure usually starts developing in tube when the heat transfer gets disrupted. So the failure modes can be separated into two. One is soot and unburned fuel deposition on the fire side, and the other one is scale formation and corrosion on the water side. Okay, so both conditions will cause localized heating. Okay, and this localized heating will cause accelerated deterioration of these tubes. The tube failures which we are looking at due to these failure modes are tube burst, tube crack, and tube bend. Tube burst, there are multiple types of tube burst. Could be minor, could be major, and crack as well. There are multiple types, like dissimilar metal well crack. Due to thinning of material, it cracks. And tube bend, as we know, different heating areas and due to temperature difference in the material, and the tube starts bending. So here you look at a damage, okay, on your right. So I'm going to explain further now on what could this deposition do. When you say fuel deposition, it deposits on the top or the fire side of the tube, and this deposition of soot and unburned fuel is very corrosive to the tubes. So it's going to thin the material, and as time goes, the pressure inside the tube is going to be the same, obviously, but the tube is going to unable to withstand the pressure, and it's going to burst open like this. Okay, this is one type. And the number two is scaling. Scaling is caused by salts or total dissolved solids inside your boiler water. When they are not treated properly, when proper maintenance is not done, scales are going to form inside your boiler tube, and it is going to choke your tube. Choking of tube is going to starve your tube. When it starves, when the tubes are starved out of water, heat transfer will not be there, and number one, localized heat is going to occur. So your same type of tube with the same material is going to get heated at different temperatures at different areas. So this will cause a lot of mechanical stress to the tube, and it will fail eventually. So how do we mitigate this? What is the risk assessment, and how do we mitigate this? Boiler water tests must be conducted regularly to look at the parameters. The parameter range is usually provided by the manufacturer in their manual, and you should follow that accordingly. And soot deposition is also must be achieved by the previous things which I've told you. FD fan and your boiler. If your atomization is proper, if the air supply is proper, there is not going to be any soot deposition inside your tube or outside your tube, the fire side of your tube. Okay, so you will be able to mitigate that. How are you going to achieve this further? Is that by doing periodic cleanings on the tube on the fire side. Okay, it can be identified by how long it takes for the boiler to achieve the steam pressure required. So, as a failure investigator, um, you go in and you look at your boiler. They say that the boiler is not working as how it's supposed to be. There are many damage in the boiler. That is wrong. This is wrong, or whatsoever. Or they are giving you some other reason. So you go over there, and what you need to do to understand the boiler's performance is that you start up the boiler and look at how long does the boiler take to increase 1 degree of pressure, or 1 bar of pressure. Sorry, not 1 degree, 1 bar of pressure. How long does it take? How many minutes or how many seconds does it take? The boiler manual or the contractor which has installed the boiler will have a shop test or a construction parameter. Okay, in this shop test, it will show you how long the boiler took to increase the pressure of steam by 1 bar. And now you compare with what you have in hand. So if the comparison is good, the boiler is good. But if it is not, then something else is wrong over there. It could be your tube has been damaged and it's leaking. Okay, or it's due to this. You have a scale. Okay, you have a scaling inside your tube. This is what you see, which is what you say as scaling. It chokes your tube to the maximum where it does not allow water to travel anymore. In this kind of manner, first you will have your boiler struggling to produce the steam pressure required in a short period of time, and later when this situation is unattended to, it's going to fail the tubes one by one. Okay, so what are the other types? As I said, you can see soot deposition as well. I'm going to show you a picture in a while, but before that, what we are going to see, if a tube is damaged or failed. Okay, if it is a major damage, you're going to see water level drop, drastic water level drop in your system. Number two, your boiler will not be able to sustain its pressure. Let's say you're going to push your boiler's pressure to a certain limit, and then you're going to close your valves. What you're going to see there is you will not be able to see the pressure sustaining there. It's going to keep on dropping even with your main steam stop valve shut. So that indicates there's a major leak inside your boiler. Okay, and white smoke observed in your chimney, on your chimney, while your boiler is not working. Okay, and wet furnace noticed during your normal periodic maintenance. If you see wet furnace there must be a leak. It could be a minor one. So because if other three on top is not having any issue, but you see a wet furnace, it could be a minor leak. Okay, so what could lead to that from the fire side is soot deposition. This is how a soot deposition and corrosion on the boiler tube will look like. Okay, so we have completed the first section, combustion and heat transfer of boiler and the components involved in it. We are going to go into boiler mounting now. So before we go into boiler mounting, I am just going to have a look at the questions here. So the first question by Andres Adianto is: the FD fan in boiler with diesel, or what is the periodical testing and that shall be done to fins, but still consider practical, economical, practical. Okay, Andres, I'm a little bit confused with your question here. Okay, FD fan will always be there for any sort of boiler because your boiler needs to burn. So in order for it to burn, it needs air. Air is supplied by this FD fan. And when you talk about fins, that shall be done to fins. I'm not sure if you're talking about the fins on the boiler tube, because fins by meaning are you talking about the impeller of the FD fan? Because FD fan impellers do not require periodical. Sorry, I won't say that, because you do require a periodical cleaning, but they are not full of dirt. You see, so the length of periodical maintenance required for the FD fan impellers or vanes are a longer period, and you can determine if they are going, if they are not functioning well by looking at your smoke. If your smoke is not good, it's either your fuel or your air is having an issue. So you need to look at this both. Then you go and look at your control panel. If the opening percentage shown in your control panel is in tally with your FD fan's actual opening percentage. If they are not, then you need to adjust that. Okay. So this is what you need to do in order for you to determine that. Okay. So I believe I've answered. If I have not, then do comment back. Okay. Methods to detect scaling inside the tube other than observing localized heat. Okay, your boiler will struggle to produce. This is to Amendi, Amendi Lokito. Your boiler will struggle to produce the steam it is required to produce, because now, like, just imagine your heart pumping blood to your brains and you have a choke in your one of your arteries. What's going to happen? Your heart is going to put a lot of pressure to, struggle to push the blood to your brains. Same thing the boiler is going to do. The water is going to absorb all the steam required, but it is going to struggle to move up. So your boiler's performance will reduce drastically if it has been choked. Okay, that is the first ever telltale sign. If an operator has been vigilant in looking at his boiler, then he would understand that the boiler's capacity or performance has been dropping. Next one, Mr. Charles Bodie, I noted some points could be critical. However, for burning matters inside the boiler are impossible to check, such as accumulated unburned fuel. If it is the proximate cause that created explosion, able to subrogate to the manufacturer, maintenance, specialist coin. Mr. Charles Brody, it is not impossible to check the unburned fuel, because you see, if it is a vertical fired boiler and your burner is at top, you're going to have your boiler, the burner, giving up the atomization in a Y shape. If it is too much of an angle, it is going to splatter the unburned fuel towards the tubes. Okay, so if you have a furnace explosion, the explosion usually occurs from the bottom as well. So your telltale signs is to look in between the tubes on the furnace walls and also at the bottom. You are not going to have a fire in the furnace bottom, you're going to have an explosion. So when it explodes, it is still going to leave a lot of area with unburned fuel accumulation. Okay, talking from experience, I have seen this, and an operator should be able to pick this up, because every 6 months we will do a boiler furnace inspection, swirler cleaning, and burners are actually serviced every week. Being a marine engineer, I used to do that by myself, and we used to do it every week. And when we do a 6 monthly furnace inspection, we will inspect the furnace of a boiler in detail to see whether there is accumulation of unburned fuel. But if you want to achieve, you ask, I understand where you are coming from, you want to achieve this after the incident. So after the incident, you just need to look at the bottom of the furnace. Usually explosion occurs from the bottom, but the splattering occurs around the area of the bottom. So you will be able to find at least minimal amount of unburned fuel. You can collect that and send it for a sample test, and the lab will come out with an answer to give you how long could the fuel be accumulated over there, the kind of stuff. Okay, Andreas Adianto, for tube, not for fan anymore. Understood, thanks. Okay. I believe that for now, I've explained whatever is required. David Townsend, can unburned fuel, incomplete combustion fuel, escape from the boiler and be ignited then by another source? Very, very possible, Mr. David. If the unburned fuel, the amount is too enormous during your purge, that is the reason you actually purge your boiler, pre and post purge. You want to get rid of this unburned fuel which is still there, which is still in slightly liquid state or gaseous state. You want to get rid of it so that when the fire comes, it does not detonate and explode. So you want to get rid of it. So due time, and you're not supposed to have unburned fuel. If your FD fan and your burner is running well, you are not supposed to have unburned fuel. But this purge is done just to ensure you eliminate the factor of unburned fuel being present inside the furnace. But if let's say you did not look at one factor and unburned fuel is getting accumulated every time, when you do this purge, it's going to travel through the furnace to the exhaust manifold, and it can even accumulate at the economizer. If you are going to keep your boiler running in this kind of manner, which it produces a lot of soot and unburned fuel, this can accumulate in your ducting and economizer. Usually it accumulates a lot in the ducting, in the economizer. And I have seen economizer meltdown failures due to the reason which you have brought up. Actually, a very good question by Mr. David Townsend over here. And then, Kevin Wynn, if the steam boiler tubes are close together, is it possible that if one tube bursts, causing the hot steam to escape and damage other tubes next to each other, steam cut? Possible, Kevin Uy. That is very possible. If the tubes, the tubes are usually very close to each other. They are constructed in such a way, but depends on the magnitude of explosion which can come out from this tube. So let's say if it has been choked and you have pressurized the boiler to a certain pressure which is too high and it's going to explode. Depending on the type of explosion and the magnitude of this explosion and the pressure present inside by the steam, a steam cut is present, is possible. Okay, so I do not have any more other questions here. If I have answered your question, I'm very glad. But if I have not answered your question, if you didn't get what I'm trying to say, please do feedback. I'll try to answer it back. I'm going to go on to the next segment where mounting, boiler mounting is which is related to boiler mountings. Okay, so when we talk about boiler mountings, it is fixed on all types of boilers. It is usually a regulation by DOSH when it comes to boilers to have all these mountings in place, because these mountings will supersede any remote control and will still ensure the safe operation of the boiler if the operator knows how to handle this. Okay, so there are 7 critical essential boiler mountings, okay, which are the water level indicator, pressure gauge, steam stop valve, fusible plug, blow off valve or blow down valve, pre check valve, and safety valve. Okay, so every of this component, when I go into, I'm going to relate to a failure, and I'm going to tell you how you can check if this is related in any way. Few of it, which I have the pictures of what actually it has happened. I also have those pictures, so we can see that. Okay, so before we go, I want to give you a picture. What are the boiler mountings which we have been talking about? Number one is the water level gauge. Okay, that's the gauge glass. It is fixed usually on the vertical side of the boiler. Okay, it connects the steam section or the gas section and the water section. This somehow stabilizes the pressure inside the gauge glass and shows the exact value of the water level inside the boiler. Number two, you have pressure gauge. Okay, as we all know, pressure gauge shows the pressure. It is on the steam side of the boiler. It shows the steam pressure. And we have the stop valve or main steam stop valve. Okay, this main steam stop valve is fixed on the outlet of steam. Okay, this is the one and only valve which is directly attached to the boiler. Okay, to allow steam to flow out. Okay, so this is the steam stop valve. The details of these components I'll go through as we go down the slides. Okay. Number 4, fusible plug. This is a plug which is a last line of defense if your boiler keeps firing still and your water level is too low. It's going to melt and it is going to release all pressure into the furnace to cut off the fire. Okay, and 5, the blow down valve. Okay, if I tell you a little bit of detail, then it won't be much of interest later when I explain further. So we're going to keep your minds onto this blowdown valve. I'll explain further as we go. You will find one at the far bottom of the boiler, one at the top section of the boiler. Okay, and then the main feed valve or feed check valve, that is the valve which feeds the water required for the boiler to operate. And finally you have the safety valve. As the name states, the valve is for a safety function, last line of defense. When the steam pressure exceeds, it's going to release off the steam pressure when the steam pressure is too much. Okay, so we're going to go into water level indicator first. Okay, you have got the whole list of details I know listed out on your left, and this is how your water level gauge glass or water level indicator looks. Okay, what and why is this required? Okay, you might ask yourself, why is this so important? It's just a gauge. Okay, there are times when your remote monitoring is not uh, as efficient as it's supposed to be. You know, electrical components, they fail. Sometimes the signal transmitter is not right, is slightly low in voltage. You are not able to get the right amount. So as a boiler operator, he needs to check this gauge glass time and again that they are working. And when you look at the gauge glass, the water level inside the gauge glass should have some sort of movement, a slight movement. If they are not moving, that means your gauge glass is choked. You need to perform a blowdown on your gauge glass to clear the choke line so that it is back to normal. Okay, and the procedure to do a blowdown on this gauge glass is tedious. So that we can leave it for another session. Okay, so this indication of water level in your boiler supersedes the remote monitoring system, and your remote monitoring system must always match this, because you're going to be always with your remote monitoring system in the control room. You're not going to be at site on the boiler. So what you need to do is you need to make sure that this and that is in tally. You might ask me, how is this going to help you in your investigation? Okay, I'm sure those who are involved in failure investigation or machinery claims, engineering claims, you would have came through multiple times boiler tubes bent or boiler tube and the dissimilar metal there cracked. 1 second, I'm just looking at a question. Is an ion exchange resin tower a boiler or pressure vessel or just a vessel? Okay, I will explain further when I go down, because I'm talking about the water level indicator. This looks like a different question asking about what type of boiler is it. I'll come to that, Miss Eileen Chu. Okay, coming to this water level indicator again. Okay, so when you have a low water level condition, and when you go and investigate a failure where your tubes are bent or you have a crack at the well edge, please go and have a look. Two things. Number one, obviously look at the alarms, what it has triggered. If it has not triggered alarms, please go and look at the gauge glass and make sure, tell the guy to dismantle this gauge glass. I'm going to switch to pointer. I'll even show you how you can dismantle this gauge glass. You can see two nuts over here, two nuts over here, and two nuts over here, two nuts over here. If the boiler is not in operating condition, okay, you can immediately take off these two nuts, no matter whether the valves are closed or open, and take off this whole segment out from the connection, and you can inspect this gauge glass whether they are choked or not by that. Okay, that's number one. Number two, if it is working, there is a procedure to how you can dismantle this gauge glass from in place to determine whether this thing is choked or not. Okay, a boilerman should know it. You can tell him to do it in front of you to determine whether this gauge glass is not choked. Okay, if it is not choked, then probably it could be a transmitter issue. But if it was choked, that means both systems which they have, the remote and the essential system to determine the water level in the boiler, has failed the operator, and it is usually due to their fault. They don't do a proper maintenance. So I'm going to show you what can happen if you don't, look at, okay, this is just a sketch on how this gauge gas is connected to the boiler, and I'm going to show you now what will happen if you don't monitor your water level. Okay, this is exact condition of what is happening with what has happened with this boiler. Okay, it's a horizontal smoke tube boiler. Okay, what has happened is the boilerman has started this boiler. He has seen the remote indicator showing good water level. He kept on firing the boiler. He looked at the gauge glass. The water was at the middle, but it was not moving. He assumed that the water is there, and he kept on firing, but unfortunately there was no water inside the boiler. Since the water level indicator got choked, it could not show the exact water level, and the alarms, the level triggering alarms, were also having issues, so they were not able to function well to cut in the feed water pump. When he left it firing, that's what he got. End of the day, the whole furnace bulged in due to the no water level situation. Okay, the issues which could result in damage due to water level is when there is low water level, it could damage the boiler itself. If it is high water level, the steam consumers could be damaged. You can ask how. For an instance, take turbine. A turbine is spinning at 2,500 revolution per minute, okay, and steam at high pressure is pushing or turning this turbine to rotate. And when you have a sudden surge of water into it, it's going to cause a huge disruption onto the flow, and that could cause vibration, that could cause impact on the turbine, and it's going to explode the whole turbine. So you should not have high water level. High water level is dangerous for the steam consumers. Low level is dangerous for the boiler itself. So when you say failure, if you have your boiler tubes bent, and failure investigators, please look at your water level indicator, which is one of the essential and critical boiler mounting. Okay. So next we look at pressure gauge. Nothing much on the pressure gauge. Again, it is actually similar to the boiler water level indicator. This is the actual pressure indicator which is fixed on the boiler itself. It should tally with your system remote control as well. So if it doesn't, then you need to change this pressure gauge immediately. If it is not being changed, and you see, during an explosion of the boiler, it can result into damage of this as well. So what you can do is that you check the remote system on how much was the pressure seen in the remote system. At the same time, finally, you look at the safety valves. Later, in the final stages, I'll explain what is a safety valve and how it works in tangent with our pressure gauge. I'm just quickly going to look at the questions. Isn't the alarm going to be triggered if the water level is low, even with the indicator broken? Mr. Adi Saleh, I'm going to explain further. Alarms are electronical equipments which can fail. If your water level is not detected in the water level indicator, your alarm can still fail. The previous slide, okay, this slide which I showed you is a live example. I'm not sure if the adjuster who attended this case with me is present here. His name is, I don't want to reveal his name, sorry. Yeah. So this person was also with me attending this case. I saw his name in the list. I'm not sure whether he's here now or not. So in this is a scenario where there was no indication of this low level alarm because the alarm got stuck, and our friend, the man who's supposed to look at the water level indicator, the manual indicator, he did not look at it and he kept on firing the boiler. So in this scenario, exactly as what you have stated, the alarms were not working. The floats or the capacitance sensor was not detecting the water level, and this caused this sort of damage. Okay, going to go back into pressure gauge. Before that, I'm going to answer Kok Chi Kang's question. Water carryover can cause serious corrosion, erosion on turbine plates and vents. Correct, Mr. Kok Chi Kang. Minimal carryover can cause corrosion and erosion, but a huge carryover can cause abrupt damage, immediate damage. Okay, you do not want water to be present in your steam site. That's why you have actually steam separators, steam traps. Okay, that would lead to another discussion. So I'm going to keep it there. But point stated by Kok Chi Kang is correct. It can also cause corrosion and erosion on turbine plates and vents. Okay, you have a pressure gauge here. I've spoke about the pressure gauge, and it will work in together with the pressure relief valve, safety valve. Okay, before that, we're going to look at the steam stop valve. Okay, this is fixed on the exit of steam on the boiler itself. It is there to regulate the flow. Okay, the flow regulation is done by this steam stop valve. You may ask me, what is the difference? Why do we need? Is this a special valve? What is the difference between a normal conventional valve and this? Okay, this valve has two specialty to it. Normal valve, the moment you turn the spindle, it's going to immediately lift the valve. And the control on the valve lift is in a very big ratio. So the moment you open, you're going to open it a lot. Steam stop valve, what it's going to do is your control ratio is going to be very small. So you can keep on turning the spindle and your valve lift is going to be controlled by your opening of spindle. Okay, so as it goes up, you're going to release more steam slowly into the steam system. Okay, so that is why the steam stop valve is present. That's number one. Number two, this steam stop valve allows only one-way flow of steam, and this one-way flow will assist in not damaging the steam consumers. How can you check how this valve is working or not? Just pressurize your boiler to the maximum pressure allowable, maximum allowable pressure, and then stop your boiler, shut your valve. Or you can shut your valve and keep going with pressurizing your boiler as well, because your boiler is able to withstand that amount of pressure with the steam stop valve being shut. And then monitor the pressure. If it doesn't drop drastically or rapidly, then means that your steam stop valve is still working and it's not leaking. And how are you going to look at the reverse flow? You can have a look through the gauge given. There should not be any vacuum created in the steam outlet. Okay, so we're going to see a drawing here of the steam stop valve. Okay, I've explained whatever is written here in the previous slide as well. Okay, so I'm going to switch to laser pointer, and we're going to go on here. You can see the gland. Okay, it's a packing, it's a jute kind of gland, sometimes Teflon, sometimes graphite. Okay, sorry, not graphite, Teflon and jute. So this item which is here is going to separate the steam area and the outer area, and is going to hold the steam in place and not letting it leak. You're going to have a yoke and a stud. The stud will tighten the yoke to hold the gland in place so that there's no leak. And you have a valve seat, and as you turn the spindle wheel, the valve lift is going to be there. Your inlet of steam is here, and it is going to flow on out to this area. Okay, to this area. So if in any case, there's also to eliminate if in any case this thing fails, you will have another check valve as well outside. But if there is a reverse flow, the construction, the L construction of this steam stop valve is not going to allow a backflow into it. It's just going to come back and hit, and it is going to stay there. It's not going to flow down to the boiler. Okay. So this is your steam stop valve, one of your boiler mountings, and I'm going to repeat. It regulates the flow. It does not allow a return flow. This two. How are you going to test? Pressurize the boiler to maximum, close the valve, and see if the pressure drops. That's number one. Another test is there is no vacuum created in the exit of this steam. Okay, now fusible plug. This is an interesting one, and mostly investigators leave this out. Operators do not bother to look at this. The fusible plug is the last line of defense in a scenario of water level indicators fail. Okay, like what Mr. Adi Saleh said. Okay, if your indicator fails, if your remote system fails, and your physical system fails, you still do not know, you keep on firing it. The last line of defense is this. The moment the water level drops below the fusible plug, the fusible plug usually is submerged underwater. Okay, so this fusible plug is fixed in a place which is in between the fire site, the furnace, and the water area. So what happens now when the fusible plug is submerged underwater? The heat absorbed by this fusible plug is still dispersed back to the water. But when this fusible plug is no more submerged underwater, the steam itself increases the fusible plug's temperature. And I'm going to show you the construction of this fusible plug. The whole segment, the body of it is made by gunmetal, which has higher melting point, and then they have a fusible metal which has a very low melting point. So the moment the steam touches this fusible metal, it's going to melt the core of this fusible plug, and it's going to release all the pressure from the steam side to the furnace. So in a case of boiler meltdown, everything failed, tubes all melt down, and you go to investigate this. What you need to look at is this fusible plug is there to eliminate this condition. So find the fusible plug. I am unable to tell you where exactly the fusible plug might be, but there will be a fusible plug. So in order to ensure where exactly it is, open the manual and look at the construction drawing, because every boiler will have its fusible plug at a different area, but you will find it at an area between the water and fire site, where it can release the steam from the water or the steam site to the fire site to starve the boiler of boiler's fire, and cut off the fire immediately. This is to prevent tube meltdown, a boiler tube meltdown. Okay, so if you ask me how you're going to determine this, if you see a boiler meltdown, find the fusible plug, check if the core has a hole in it. If it does not has a hole in it, that means your fusible plug has failed you. There's no maintenance to this. Usual lifespan of this fusible plug is about 10 to 15 years. Usually manufacturers will let you know to change in every 10 years. Okay, every 10 years you need to change this fusible plug during your major overhaul or major inspection of this boiler. So check on that, check on the maintenance parameters, maintenance checklists or logs to check when was this fusible plug last changed. So if a meltdown has occurred, either after the activation of this fusible plug, fire was still present, or the fusible plug did not activate, that's why fire was still present and it damaged the whole boiler. So now we're going to look at blowdown valve. Okay, blowdown valve, I've spoke to you about scaling. I've told you what scaling can do, and this is one of the mitigation measures which is required to reduce or eliminate scaling. You do blowdown. You have two valves, one at the top. You call it as skimmer blowdown or scum blowdown, and then you have a bottom blowdown. Bottom blowdown sucks out all the sludge, the sediments beneath to reduce salts and total dissolved solids, and on top you'll have scum blowdown to remove the floating solids on the boiler water. Okay, so when you do that, you're going to remove this and you're going to maintain the property of water. I see questions are coming up a lot. We are going to finish with the slides soon, so once we are done that, I will come up with answering the questions, and we can have an interactive section. If I'm not giving you the answer you require or you're confused, you can always ask me back. We can have a discussion. Okay, let's finish the slides first. So the blowdown valve does that, what I was telling you just now. Is going to reduce all the total dissolved solids, the sludge, the foreign particles, whichever which is not required. So how can this cause failure? If your tube has choked, let's say as a failure investigator, your tube has choked and your insured is showing you that the tube has been choked, and you are attempting to investigate the situation. First and foremost thing you need to do is go and look at your blowdown valve. Okay, if the boiler does not have water inside it, you can open it by yourself. Okay, open the blowdown valve by yourself. It will not be very hard to open, slightly hard but not very hard to open. A man can open it. Okay, if it is stuck, then I can assure you there was no blowdown done to this boiler. If there was no blowdown done, now you know why the scales have formed. Okay, or if there is water inside the boiler, get the boiler man to do that for you. Okay, that's number two. And then also other failures such as water loss. You also can look at these valves and the scuppers of these valves if there is any traces of water. If there are any traces of water, then that's one of the reasons why the boiler is losing water. Okay, this could be one of those reasons. Okay, so you have seen blowdown valve, and I'm going to explain the blowdown valve construction. This is another special type of valve. It's a needle valve. You see, your boiler water is being pressurized by steam above it. So this pressurized steam is pushing against your water, and if you open a valve beneath, you're going to have high velocity of water gushing out. This will carry a lot of sediments, foreign particles. If you use a conventional valve where your surface for seating area, valve seat area is big, this sediments is going to layer on the seat and is going to spoil the valve. You will not be able to close the valve well, you're going to have leak. But a needle valve will have a very minimal surface contact for sealing. It's like a plug. So if this part gets damaged, you just thread it in even further, it's going to go on. But you should not force it much though. So it gives a minimal surface contact point to seal, and it gives a tight seal. That is the reason why a needle valve is used in blowdown valves for boilers. So next is feed check valve. As the steam valve, steam stop valve, which I spoke to you, this is a similar construction valve. Okay, while the steam stop valve allows steam to go one way from the boiler to the steam consumers, this feed check valve is going to allow water, feed water inside the boiler one way, doesn't return. What happens if there is a water returning out of this valve? Okay, imagine a boiler, steam flowing out, one way flow, and then you're supposed to have water flowing in. But if there is a reverse flow, imagine two pressure acting on a pressure vessel and opposite directions. So there's going to be vacuum created in the middle and your whole boiler is going to inflow. So I've given you the word inflow. So if you are going to check on boiler implosion, go straight away and check your feed valve. Number one, very, very important. Check your feed valve. How is it working? Is it able to do what it's supposed to do? Okay. And number two, also have a look at your vents. They are not in your boiler mountings, but it is part of the boiler, which can also cause implosion when the boiler is being shut down, only during shutdown. Huh? So in this condition, you can ask me, how can I determine whether my feed check valve is working or not? I'm going to investigate and the boiler is imploded. I go and see a feed valve. I see a feed valve, yes. But how am I able to make sure? You can tell the team to fill up the boiler with water, even though it is imploded. Okay, just fill up, not to operate the boiler, just fill up a little bit. Okay, and now with the valve open, please take note, with the valve open, you open up the inlet to the valve. In this condition, you should not see any water flowing out of the valve because this is a non-return valve. There's only one way flow. Okay, you might be thinking, if the valve is open, can I have water flowing back? You should not. If the water is flowing back with the valve open and your inlet to the feed water taken out, that means the valve has spoiled and that has caused an implosion of this tank, this boiler. Okay. So now finally we come into safety valve. Okay. You're looking at a GIF image there. It is a simple valve. Okay. Uh, I'm going to change into my pointer so that I can show you better. This is a test lever to test the lifting of the valve. And the moment you lift the valve, it is going to pop back on the seat. So it should pop back on the seat. This is to show the reactiveness of the valve. And the spindle of this valve is spring loaded. You can see a spring load over here and a valve over here. Okay. So spring load and valve is over here. So what happens when the steam pressure is above the spring load pressure, and the valve is going to lift and release the steam. So how this spring load is set is by means of nut. You will tighten the spring to a certain pressure which is equivalent to 80% of the boiler's maximum allowable pressure. Boiler manufacturers will not allow the boiler to operate to 100% pressure. Okay, they will always only allow the boiler to operate at 80% pressure because that 20% is a tolerance value left. Let's say if the pressure did go high, your boiler will not explode immediately. Okay, so this is how it works. This is how it is constructed. Okay, so what it does is it will immediately release off pressure and then brings the pressure back to a nominal value. This is the final line of defense for pressure, okay, in a boiler. So this safety valve, this is how it looks physically. This safety, if you ask me, how can we ensure that this safety valve is working? Let's say you are going to go and inspect a boiler's explosion due to pressure. Okay, not the furnace explosion, but due to pressure, steam drum of a boiler is exploded, and you need to ensure that these valves are working. You can dismantle the valve, bring it to a test bench, fix in pneumatic air, okay, and increase the pressure up till the value stated in the manual. The manual will give you the value, how much of pneumatic pressure you should increase to test if the valve is lifting at its supposed state. Okay, so you do that. Okay, and for risk, those operators, what they need to do is they can do a physical test, put the boiler on manual, fire the boiler, bring it to its maximum allowable pressure, just slightly above its maximum allowable pressure, and this valve will lift. Do not go near to this valve, stand away, okay, and see the valve lift. It's just going to lift very immediately and shut off immediately. It's just going to release off and shut off, release on, shut off. This is what we need to see. And all these boiler mountings are regulations by JKKP as well, or DOSH. These mountings are something which is required by DOSH for it to function. If they don't function well, they can lead into catastrophic disaster. So we have looked into those basic items and what kind of failures they can cause if they are not functioning, and how a failure investigator can look into solving issues with this. Now, since I've gone through all, I'm going to leave it at question and answer. I'm going to answer those who have written there first. Okay. Adi Saleh, I have Water carryover, I've answered. I see before and during firing. Will the water level move a bit up or down or remain static? Okay, perfect. Good question. Can I scroll that? But I'm not able to see the. Okay, nice, perfect. So, Mas Ashraf, okay, if you're going to start from cold start, okay, let's say your water level is at certain level. When you start, when the pressure increases slightly, you are going to see the water level suddenly shoot up a bit more than usual because it's due to expansion of water. Okay, and then after some time during firing, if the steam demand and the load and as well as the water feed is all in proper manner and the controllers are working well, you're going to see the water level perfectly at that point. You will only see the water level dropping if the steam demand is too high and your water feed is too low, and then you will see steam demand dropping. What you want is perfect feed into the boiler while the boiler is processing the steam required. Okay, I think I've answered that. Mohammed Mas Ashraf and then Tiban Vasandan. Does the steam stop valve and junction valve have the same principle? Um, I do not know what is what do you mean by a junction valve? Maybe you can try to elaborate further. What do you mean by a junction valve? Are you talking about a T valve? You know, a three-way valve, two-way valve. What are we talking about here? Steam stop valve is a non-return valve which allows one-way flow and regulates. That are the two functions of a steam stop valve. Okay, coming to Kok Chi Kang, overblow down. What would be the consequence? If you overblow down, you're going to lose all the chemical properties of your boiler water. You're going to lose a lot of water. So you need to answer to your company why you have lost that much of water. If you overblow down, your chemical properties are going to drastically drop. Then you need to dose back your chemicals to keep your chemicals in line. Mr. Fauzi, do you know what type of inspection scope of work carried out by DOSH during the boiler inspection for certification? If all the preventive maintenance which you mentioned carried out by DOSH and the boiler is certified, can we conclude the boiler is safe to be operated? Mr. Fauzi, DOSH does not do preventive maintenance. Preventive maintenance is done by the operator. You can conclude if DOSH certifies the boiler, it means that during the time of DOSH inspection, the boiler was safe. Okay, please take note. Usually, insured and operators argue with failure investigators saying, "Oh, DOSH already inspect our boiler and our boiler is working well." So, if our boiler is working well, we do not need to say that. You cannot say that the boiler is not working. Your boiler certificate was provided by DOSH, let's say 6 months before or 3 months before. DOSH has stated during their inspection, the boiler was working up to standard. Any time after that particular day, the next day, if the boiler is not working, even DOSH is going to answer the same thing. We said the boiler is working yesterday, not today. Understand? The exact debate which is going to occur if you bring this forward to DOSH as well. DOSH is going to state that certification was provided on the day, not after 3 months. If you want to ensure the boiler is working now, you need to call us back again. Okay, that's how it's going to. So, can we conclude that the boiler is safe to be operated? Yes, it was safe to be operated when DOSH did the inspection. Whether if it is safe to be operated now, we need to inspect back again. Okay. I hope I have answered your question, Mr. Fauzi. Mr. Zigazik Zafullah bin Avoka. Level of explosion. I am unable to understand the question there. Level of explosion. I do not know what level are we talking about. Maybe please elaborate further. I'll try to answer. Adi Saleh, how many boiler explosion case, any causation have you seen in your career so far, or any record hold by a group, any similar causation, what type of damage usually? Good question. With approved group, I've seen two. Career as an engineer, I've seen, I think, 20 and above, and few of it I have witnessed by myself. It varies from minor explosion to major explosions. I have told you that I have served as a marine engineer on board of crude oil tanker. We are literally floating on a nuclear bomb. You know, a crude oil vessel explosion is equivalent to a nuclear bomb explosion. So we are very, very um, careful when we handle boilers. So record with AGI, I need to check past 20 years. I do not know exactly how many. I'm expecting at least more than 50. But during my tenure within these 2 years, I've seen two boiler explosions with AGI. But with my career experience as an engineer, yeah, 20 plus, and yeah, handled, seen. Causation can be a lot. What type of explosion are we talking about? Are we talking about furnace explosion? Are we talking about tube explosion? Are we talking about a steam drum explosion? Are we talking about a meltdown? It's a lengthy subject. So causation could be many, but usually, mainly, if a furnace explosion is there, it's due to accumulation of unburned fuel and accumulation of soot. Okay, so next is by Kalisa Sidraja. Are there any other guidelines that boiler operators should adhere to other than DOSH? To put it simply, Kalisa, if the boiler operators follow exactly what is written in the boiler operators manual, it's perfect. Because boiler operators manual, by regulations, DOSH regulations supersedes whatever manufacturers procedure or parameter value sets or standard operating procedures. But in reality, when you look at the manufacturer's manual, manufacturer's requirement on operation and how you should maintain the boiler will be way much higher than what is DOSH requirement. So best thing is follow regulations, obviously, but always follow your manufacturer recommendation when you do maintenance, periodic maintenance, operations. Everything must follow the manufacturer's manual. Mas Ashraf, relating to my question, so if the water level indicator is choked and you're firing and water level remains static, this should be an indicator to boilerman to check water level indicator whether it is working or otherwise, right? Okay, let's say I'm going to give you a scenario here. Your water level indicator, your remote water level indicator has failed you. Okay, so when you fire your boiler, what will be your immediate indication is that your pressure is not going up at all. Usually, when you fire your boiler, you need to see pressure going up, like 2 bar, 3 bar, 4 bar. But if your water level transmitter is spoiled and your pump, usually your electrical water level transmitter is connected with your feed pump. So as your water level reduces, your feed pump will, if it is inverter type, it will go faster to give more water. If it is a normal controller type, it is going to open your feed valve more. Your water is going to be in circulation. So if you don't see your pressure rising up when you are starting the boiler, run to your water level indicator and look at your water level indicator. So at your water level indicator, the manual water level indicator or the gauge glass, you'll be able to see slight movements. It's not going to like jump up and down. You're going to see slight movements. But by that, you will not be able to make out anything. So if the water level is still static and you see your pressure not moving up at all, better stop the boiler completely. Don't fire the boiler. Do a gauge glass blowdown. Means there is a method to do this gauge glass blowdown. What you do is you are going to blow this pressure inside the boiler to go through this gauge glass to clear the choking of this water level indicator. Then put it back to normal. If the water level goes back to normal, that means the water level is working. Next, before you even fire your boiler, go and attempt to look at your water level indicator transmitters. Okay, and then go and check your feed valve. It is open. If there is any water being allowed into the boiler or not. So when you complete these three triangles, means water level indicator, remote water level indicator, and feed water. All this is okay, then you're good to fire. But if not, it is hard. Okay. So some questions I will not be able to immediately answer with one answer because it's a complicated system, you see. Okay, the next question. Go up, go up. What? No, Poli has asked something. Hi, I would like to check something that is out of. Oh, yes, yes, Poli Young. It will be shared with you. David Townsend, have you experienced hydrogen explosion? How would that arise? Um, Mr. David Townsend, I have not seen hydrogen explosion, but I have seen hydrogen fire. Okay, I'm going to explain how exactly this happened. If you are well aware on boilers and the systems attached to it, I'm sure you will know what is an economizer. So what has happened? This happened in 2010 on one of the vessels which I used to sail in. What has happened is soot accumulation was a lot on this EGE, exhaust gas economizer, and vessels, ships, as we start moving on full ahead, our speed, we will shut off our boiler. We will use the exhaust gas temperature to produce the steam required for our daily operations. Okay, I mean for usual operation, not cargo discharge, but for usual operations. What has happened is the soot has accumulated so much onto this EGE, and it was a 20-year-old ship, so wear and tear was also there. This accumulation of soot and unburned fuel on these tubes has absorbed enough heat and started reaching temperatures above 1000. Okay, it was not burning, it was just smoldering at that high temperature because of due to lack of oxygen. These tubes were not burning with flame yet, they were just smoldering there. And this smoldering, when it deteriorated the tubes, what happened? Water started gushing out of the tubes to the outside of exhaust gas economizer. But in a normal person's thoughts, you will think that water, when it meets fire or heat, is going to extinguish the fire immediately. But when temperatures were above 1500 to 2000, when water came in contact with the smoldering fuel, it got disintegrated immediately, breaking it down into its molecules. So oxygen and hydrogen, you have oxygen and hydrogen, and that fed the fire even more. You have oxygen and hydrogen the moment the water breaks, and now you have enough for combustion. And suddenly, out of nowhere, I see the outer areas becoming red hot. Then I see blue flame. So what we did with our chief engineer's order, we closed down the engine room. Ship was shut off, and we activated the CO2 alarm system. We went off. We waited for everything to be, totally put off fire. We waited nearly 2 hours to avoid any backdraft or rekindling of fire, and then we attempted in isolating the exhaust gas economizer before we started back our voyage. That's what happened. So I have experienced hydrogen fire, I think twice. Hydrogen explosion, unfortunately no, because fortunately, not unfortunately, fortunately no, because I was on a crude oil vessel. So we do have equipments which has hydrogen, but not to that extent. We don't carry liquid hydrogen. My ship was not carrying liquid hydrogen, so I have not experienced any hydrogen explosion. Hydrogen fire, yes. Okay. Benjamin Roy, Mr. Benjamin Roy. Water treatment, I believe, is vital. Can we determine improper treatment as reason for scale formation? Do we need to obtain the supplier specification, or should we need to obtain the water sampling and carry out our own checking at lab to determine whether treatment was done accordingly? Very, very good question, Mr. Benjamin. I've been looking at this issue again and again, multiple boiler cases. Okay, so I'm going to put it up for you. If you have a pen, please take it down. It might help you in your investigation. Number one, look at your boiler testing values which has been done by the insured. But if they have written it, mostly it is going to be not true. Okay, they're going to just throw something, just to make sure that there's some value filled in. So, what is the next step? If there is scaling in your tube, yeah, obviously, if with that lab test, you will have something very solid in your hand to prove that the water treatment was not done well. But if there is scaling in your tube means the water treatment was not done well at all from the from the beginning. Okay, but if you want to further ensure, you can do a water treatment by yourself. There's something called uh, uh, I forgot the name of this test kit. Okay, there's a test kit which you can do, but to make it simple for you, to further validate your test results, what you can do is you can send it to lab for analysis, and they will come out with what is the exact value which is present in the water treatment. Take that, open the manufacturer's book, open up the values you see there, and that's your benchmark. You cross check. Whatever is exceeding. But see, there is a catch here. Usually, when you go for boiler failures, if it is due to their own trouble, what they're going to do is they're going to change the water fully. So, and they will make sure that the water treatment values are all good. So, hard for you to find. But the moment you see scaling, that means that is a telltale sign that the water treatment was not done well. If the water treatment was done well, scaling will not be present at all. I believe I have answered you there. Okay. Okay. Many questions coming in. Roshif is selectively giving me questions now. In your experience, has any party deliberately ignored the SOP's replacement of their entire part, which ultimately resulted in a loss? Mr. Janardhanan, lie. Yes, most of the times, unfortunately, most of the times. But I think our insurance industry works in such a way in where the policy states what the policy states. Sometimes I have felt very unfair towards the insurance companies because the policy, uh, due to the policy statements, they had to still pay, even though I felt that it's their deliberate fault. Okay, Mr. Yong Xiang. Hi, do you know that DOSH normally checks for the boiler certification? Yes, I know DOSH normally checks for the boiler certification, but I do not know whether you asked the right question or not. What causes sticky valve, which leads to steam valve failure? Sticky valve is due to your steam's condition. If you don't treat your boiler water properly, your boiler water is going to have a lot of carryover salts, high acidic value is going to corrode off a few parts of the pipeline, which is going to accumulate underneath the valve, and that can cause a sticky valve. So if you have rust underneath your valve seat and your valve, when you tighten your valve, the rust is going to be on the valve seat, going to compress against. If it is closed for quite a period of time and then you open, it's going to be stuck. So the condition of your water. Do you think nitrogen preservation is enough to prevent scaling, especially during long shutdown maintenance? I mean annual shutdown. Mm, Annual shutdown, nitrogen preservation depends on what we are doing. During the shutdown, if I'm not going to do anything with the tubes, then yes, nitrogen preservation is more than enough, I believe, because nitrogen has a capability of not mixing with moisture or water. That's why they do nitrogen purging. What does nitrogen purging do? Leaves and renders the whole area, which is traveling, dry, totally dry. So nitrogen preservation is good enough method. Usually, let's say if you order a boiler or heat exchanger from overseas and you're going to receive it here in Malaysia or anywhere around the world, let's say it takes about 3 years for you to install it. Let's say you receive it in a month, but the project is in such a way that you're going to install the equipment after just 3 years. So your particular equipment during this 3 years period, all you that you need to do is check your nitrogen gauge. The manufacturers will plug in all the areas where the gas can escape and pressurize the system with nitrogen gas to a certain pressure, depending on the manufacturer and the design. And we will be told to check the pressure gauge often to maintain the pressure of nitrogen. If it is leaking, then you need to check the seals and top it up. So nitrogen preservation is good enough to do, preserve the boiler when you are doing a shutdown. Uh, Russ, any more typing? Some other are typing as well. Adisale, would you think a big boiler explosion could have dispersion effect at surrounding building and property? Similarly, having a TNT equivalent of explosion, have you known any? Oh yes, Mr. Adi Saleh, yes. But depending on the type of explosion, you see, boiler explosion due to steam pressure rarely occurs. Uh, the boiler manufacturers have installed many items in the boiler to foolproof some idiotic operators to operate it in such a manner so that it would explode. But if someone is going to operate the boiler in such a manner, such a high pressure where it crosses its 20 bar tolerance, 20% tolerance, you are going to have an explosion in such a magnitude that the shock wave can literally damage a lot of things in its vicinity. But the one which you are talking about is a furnace explosion when you have unburned fuel accumulation, depending on how bad the boiler has been maintained. If you have a lot of unburned fuel and when it explodes, yeah, the detonation can cause, and we need to look at what sort of boiler as well. I think there are a lot of YouTube's videos as well on this particular type of explosion, which has taken off the buildings at the site, which has even taken off the whole building of a power plant actually. Okay. What does Dodge check during? What does Dodge check? Oh, that's a long list, Mr. Young. It's going to be a long list. The list is going to include all those items which I just told you. Your tubes, they're going to knock on your tubes. They're going to check the tube thickness, your FD fan operation, your water level indicator, your safety valve operation. Whatever I spoke today will be checked by Dodge during the inspection. Unfortunately, Mr. Young, I'm really sorry. I'm unable to go list one by one on the list because the list is quite long. You probably can find the list in Dodge website. You know, I hope that that information would help you. Thank you, Sujan, for sharing. Thank you, Mr. Charles. Thank you, Wilco. Thank you, Mr. Sujan. Yeah, thank you, Kopchi. We did a burst of brand new boiler which during testing and commission failed. Okay, the burst water tube, new tube, was cut and sent to Japan, Italy. The result that came back was bursting of new water caused by hydrogen embrittlement. Okay, simple answer. Hydrogen embrittlement is a manufacturing defect. It is not an operator's defect. Hydrogen embrittlement happens during welding. Okay, if you don't preheat your item properly before you weld, or if you don't do a proper heat treatment on your welding after welding, hydrogen can be trapped in that area and hydrogen embrittlement can occur. It can occur with your wet welding rod, number one. Number two, it can occur by absorbing the hydrogen around the vicinity or some other values which the dissimilar metal well has. So, layman term, it's a manufacturing defect during welding, hydrogen embrittlement. Okay, guys, I think, thank you. We have wow, 2:30. Now we are at 4:11. I didn't realize the time going. Thank you so much, guys. Thank you so much for the feedback, and everyone has been sending questions. I thank you enough for attending my webinar today. Thank you again. No words. Very happy to see you all. See you on my next webinar. When we have the time, we will put it up as usual, and you all can join us. Thank you. Yeah, still the same progress.